I want to present you a little bit about GridWarp and GridWarp Tracker, which are basically the same tool, but GridWarp Tracker is an extension of it. It's an improvement, and let's see what's the difference about them. And yeah, I wanted to talk about this tool because I think it's a little overlooked, or maybe it's not that popular. At least that's my feeling because I haven't seen many people using the tool. And but I think it's pretty useful. And I think probably it's not that popular because maybe the first version of it, the Grid Warp, or it was not so friendly user, or not so reliable, was a little buggy, uh, or so efficient. So over the time it became better. Um, and then in from version 12, I guess, uh, GridWarp Tracker. I mean, from version Nuke 12, uh, we got the tracker version of it, which is even better, and it's really much more efficient than before. So, okay, so let's get started with it. So we kind of start with the difference between them. Basically, GridWarp has the possibility to do warps with the grid, but GridWarp Tracker does the same. So it's an update of the version. We still have both tools. You can use both, but you can do the same with GridWarp Tracker. And the new thing is that you have smart vectors to track your grids and do really fun stuff. That's the main difference between them. And another great thing that you have is that you can add adjustment grids, which are very useful because you don't have to you can add new keyframes without moving your original keyframes that you had before. So yeah, let's go to some use cases, some examples, and let's see how is this working. First of all, let's start with the grid warp, with the normal one, and let's see if we can cover some things that hopefully you didn't know about it, or we can just do a quick recap. So grid warp. Uh, yeah, when I started using this tool was sometimes a little difficult to use or not so friendly, but then it uh, let's make a new one. So grid warp. So when you open the tool, it has the grid on the canvas size, on your format size. And cool thing about it is that you can pick this thing to draw your boundaries, and then you can draw a new shape, a new grid, so easy like that. And then with this tool here, with this pointer, I don't know how is that called, insert mode, you can add rows or columns to your grid. And that's super easy to get a new grid. With the minus of the same tool, you can get rid of rows or columns that you don't need anymore, and then it's super easy to have a grid that you need. And from there, so this is something was not from the beginning, and then you can do it like this. So okay, I would recommend you to do your grid viewing the node before the grid indeed. So you can modify it without seeing the warping you are doing. And once you place the grid in the area that you like, that you need, you can copy the values of this grid that you just draw and paste it in the source grid. So here you have the source grid and destination grid. So that's the basic idea of the tool, that you have a source grid and destination grid. With that, you can play around like with what you would do with a corner pin. So you have a source, a destination, and you can, by default, the grid warp has just the destination grid visible. You can put both invisible, and then you will see what you are doing. So when you copy the values from the destination to the source, that means both are the same, and then you don't see any changes on the image yet. So once you place your points, you can visualize what you have done, and you can start playing around. So the basic thing would be a simple warp. Let's just extend this a little, and then you can see, then you have something done. Okay, so we accomplished something. And then from that point, you can add um, keyframes, no? If you want to make something fun here, then you can play around with it. Okay. So that's the basics of GridWarp. You have other tools here to subdivide your mesh if you need, like vertically, if you select some area. Whoop, I rotated that. Or you can subdivide the mesh horizontally, or both. If you have some points, there you go. So you have more resolution to work with. If you don't like it, you can always get rid of that. And that's great because you once you add points, they are adapting to the shape you already have there. So you can play with more resolution, or get rid of certain subdivisions that you don't need anymore. Okay, so now we can start playing with a GridWarp tracker. Okay, so I have a crop node here. It's good to optimize your area. Okay, yeah, we have great actor here. So you have your full frame to work with, and you can crop the area that you need just to optimize your resources. No, um, we have 10. Let's add a fresh one. GridWarp Tracker this time. So what this does, it has more or less the same controls as the GridWarp. Uh, by default, you are looking at, well, I mean, from and to grids, source grid and destination grid are both activated visually. So if you like, you can, if you are used to it, you can turn this off, no, the source grid. Uh, I would do the same method, going one node before to start placing our grid. So in this case, let's take the face. So I will do this because the face will be moving, and because of that, we will use the great advantage of using the smart vectors that I rendered previously. So here I render smart vectors of the image to help us with the tracking. So we connect that here. We have already agreed. Um, Before start tracking, we can place our grid however we like. So in this case, let's try to go and place some subdivisions wherever we think might be useful. In this case, let's say around this eye. Let's say that we want to modify this eye. So let's add some subdivisions there. And the thing with the tool, at least how I use it, is I don't touch the boundaries to have to not have kind of artifacts around the image I'm tweaking. So if I know I will be modifying the face, I tend to leave an extra space from the area I want to modify to the boundary, so I don't touch the boundary, and I know this area will be preserved. By default, the GridWarp Tracker has the effect we are doing over black. So we are playing this and the background is black. Um, you can turn that off and you can see the image over the source. Okay. So once you have placed your grid however you like, you can start tracking. But yes, okay, let's do something before. You can copy the values from the destination grid to the source grid just by clicking here. You have the chain symbol and you can click there and you will automatically copy all your keyframes, and these both keyframes will be linked one to each other. So if you modify something here, will be modified on the source or vice versa. So one quick way to copy values would be just clicking here, and if you from that point decide to not have them linked, you can just uh, unclick here, but you already copied those values. Okay, let's see if later we can have some use on that. So let's say we had a great grid that we will be using, so we can start tracking. Important thing is that for this function, using the smart vectors, you need nuke x. Okay, so let's go, let's track some frames. And as you can see, it's already following the movement. And one interesting thing about using smart vectors for this track is that you will be tracking small movements, micro movements, uh, like facial expressions in this case, and that can be pretty useful uh, for many tasks like cleanup or facial expression enhancement. We will see that later. Okay, so let's track some frames. There we go. Okay, so what do we have so far? We have a grid, which is tracked to the movement, and the source grid and the destination grid. Now they are not linked, but we can do that. We can copy again the values by clicking here. So we can pick a reference frame, in this case 1031. We can copy the values to the from the destination to the source grid. If we click again in yeah, to unlink the both grids, we can in this case erase the keyframes. Yeah, let's do that. We can erase some keyframes from the destination grid, and what do we see? We see an stabilized face in those frames. Okay, so we have something there. Let's undo, and we have again all the keyframes. So if we want to warp something, we can add an adjustment layer. What does that mean? It will create a new layer with the same grid, which is already tracked to our subject. And this grid has 0 keyframes so far. So we can add some, let's say that we can that well, we can turn the visibility of the other grid off, and then we can, let's say, make the eye bigger. So we have this, and so now we have something that we couldn't do before with the grid warp, which is modifying something with a tracked grid, and there you go. And you can add, of course, um, keyframes. So then you have two keyframes inside there. And you can have additional adjustment layers to that one. That's great, I would say, because in this second adjustment layer, you can change, I don't know, another area. Let's say the nose. Let's make nose bigger. And there you go. If you don't like this last transformation you did, you just delete this adjustment layer. There you go. And you keep going. You can delete this one as well. And yes, so you could potentially use this same node if you want to use it for different tasks. Let's say in this case, you can adjust something by warping it, like changing one shape, and at the same time you can use the same node for cleaning up some, I don't know, birthmark or whatever you need to clean up. Okay, so that would be the basic function of this, warping something directly. Uh, okay, then we can move on. Well, of course, if you have questions or whatever, please stop me, or yeah, or
Uh,
if you want to add
can
something to it.
can I ask a question before? So you had grid warp, and then you had a sub grid warp, which is like basically another grid warp.
Yes,
Um, and but it was the son of the original grid warp, and
yes,
you added another one on the lip area.
yes,
There's a and it was the son of the adjustment layer. So it was the two, then adjustment, and then adjustment two was the son of it. Can it
yes.
can they be brothers, or do they have to be the son and the son and the son, like inside? Do you understand the question?
Yes, let's see. I'm not sure. I haven't tried that. So
Because it's
in in
dependent
this in
on the
this
first.
layer, let's say we modify this eye. Okay.
Yeah,
Then we create another one, and in this another one we modify the other eye. If I erase the first one, which could be screen right eye,
yeah,
the modification stays from for the other eye. So I would say both are brothers instead of son and
yeah.
son of the son. Yeah,
Cool.
looks like that. And yeah, so well, yeah, that's an interesting question. This GridWarp Tracker, I haven't used that much actually, but seems that you can add more and more things and keep playing. I don't know if that's like an infinite number, but
Yeah, that's very useful though.
yeah, it's super useful. And so regarding what are the difference between both versions, the third main difference is here, this button invert next to the output warp. So you are looking out, you are looking at the output warped version, and you can invert this. So if you modify the eye here, you make it bigger. You can press this button here, invert, and then it swaps the destination grid with the source grid, and then you will get the invert result of it.
So basically, if you have an animated warp, you can warp it, then put something in the next node, and then just copy paste and invert, and it will just basically warp the paint that you put between them or something like that.
Yes. So it is much. In this case, it inverted our warp thing with it. With our, it inverted our modification in warp wise world that we did, but also can be helpful, as you said, for cleanup, because you can have, let's erase the, if we erase the source keyframes, let's do it here. What happens? Then we get an stabilized version of the face. And then from here, you can paint something out. You can do a cleanup. So let's do it. You can paint something. And then, well, that's actually other thing to consider is, you don't, once you track something, you don't have to connect to have it connected all the time to the smart vectors. It's already baked in the track. If you place again the same GridWarp tracker you had, you can click again in invert. Okay, so let's put this in all frames. You click in this button, and then it's inverting what you just have done. So you can have tracked already your auto paint. In this case, well, you could do that with a normal tracker because it's no much micro movement what we see in the eye right now. But let's see an example where it can be helpful whenever, for clothes, for example, or facial expression, that you can really take advantage of this micro tracking with smart vectors. Okay, so let's go there. We have one example here where we tracked again the face. Let's go to some area where we have more expressions, like this here. So the original one is doing this. Okay, I don't know what he's looking at, but it's doing this face. And then we already tracked this. I went ahead, I place what I did before, a nice grid following the areas I wanted to. And then what I have done there is erase the keyframes from the source grid, and then it automatically, instead of stabilizing the movement, is doubling, it's exaggerating the facial, the original expressions he had. Okay, so I don't really know in the real world, in our uh, common tasks, if this will be useful at some point, but you know what it's doing, and maybe someday will be helpful this. Okay, but let's see other practical examples where this can be more helpful. So let's go again back to the subject, and let's say we want to have some digital makeup or facial expression enhancements. So we have this. We already have a grid warp which is tracked, and let's paint something on him. Some, how is that called? Baggy eyes or something under his eyes. No, he's tired. So we want to do this. So we go to, in which frame I painted this? I don't know. Maybe 1080. Okay. So we paint some of this on his eyes. 1125 was my uh, reference frame. Okay, let's go there. So I copy this rotopaint node, I place that here, and well, I I will output some mask here, no, the alpha, in case I want to. Oh, well, in this case, it's not necessary, but anyways. So I freeze this frame. Let's color correct this, and then let's apply the warp. So in this case, is again removing the source keyframes of the grid, and then that means that we are match moving what I just have done. If I place them on top, then we have this. So you can see that it's following already some facial expressions. Let's go this maybe in this frame range. Okay, so yeah. So I guess most of us know already the power of the smart vectors, and this is another way of using them, no? So you can do your script in this fashion, or you could, yeah, in this case, paint something on, and well, you paint something on the source. Okay, so in this case, I am removing some wrinkles or facial. I don't know how is that called, but let's say let's remove this mutemal.
De-aging.
Yeah, let's DH this guy or birthmarks or whatever we want to do. So we paint out this. Thank you for that. So uh, let's put the lifetime to all the frames. And then, so we are doing this on a stabilized face with the same grid warp we already had. We paint out some areas and then we track this back, okay? So the same principle all over the frames. If we want to preserve the quality of our plate, which unfortunately, well, our original plate in this case is not very high quality, but we can do that. Painting, cloning our areas we want to, and setting this to all in lifetime, and then we output the mask in this area. We pre-mold this, we track this back, match move that, and we match it over the original plate. Okay, so in this case, we preserve the quality. There's another step forward in this example where we do the same thing, but we do the paint job that you can just copy from what you did on this operation. That's maybe you know that, but let's go over it. You can minus a blurred version from the original plate, place your paint job there, and plus it back on the blurred version of the original plate. So you are working on, I don't know if that's a high frequency, but some frequencies of the plate. And when you place it back, is preserving some of the luminance values of the plate, so it looks better. You can as well uh, do it with a mask to promote this result. Then you track this back and you over it. And then you remove some of the wrinkles he had or whatever you want to remove, no? So that could be a practical example for the aging or digital makeup or whatever you want to do there. Okay, Do you have a question here so far? Okay, let's keep going. So uh, another big use case task where you can use the tool is in a morphing situation. So I was thinking about it, and we actually don't use morphing in the traditional way so often in visual effects. I mean, traditional way. I have some example here, like this. Maybe most of us know this video, which is what black and white from Michael
Very
Jackson.
traditional.
I'm sorry.
Very traditional.
That's super traditional, and well, I this is playing in a fourth of the speed, so you can see it better. And well, it's actually super well done for the 90s. What thing was in the beginning of the 90s where when they did this, and so it's transforming. If you see in this speed, then you can see some technical things to improve, no? Like the sometimes it's a little ghosting or you have some roto issues, color issues, etc. But it has also some great things that like we just saw, that is not just that morphing from A to B, but it's also animating some things like the hair growing or the beard in this case revealing towards the center. Or so in order to have a great morphing, like in this case, even with the technological limitations, you need creativity, pick a nice moment to cut the thing, like maybe in a motion blur moment or etc. So, but anyways, we don't do this very often. We don't morph from one character to another character very often. Though we do morphings, at least I have done this a couple of times in the past 2 years, and that's also another reason why I decided to do this, because we do morphing in a more discrete ways sometimes. Like in this case, if you have jump cuts, um, let's say they give you like another way to look at it is would be like hardcore retimes. So where you have a character doing something and suddenly jumps 20 frames ahead and is doing something else. It was done also. Let me play this example. Unfortunately, we have already this project archived, but I found just a quick reference just to remind us, or maybe you didn't see that. I did this shot here, and in let me go back. In this shot, the black guy, which is HWR called, is jumping in time very quickly. What that means is that the other two guys cannot reach him to kill him so easily. And this was done with a jump cut fashion. That means these two guys we see on the screen were standing. I mean, in the filming day, they were standing there, and when the other guy had to move, they were supposed to not move and wait until the other guy went to the next position, and then they kept going with the acting. But as you can imagine, they were not standing 100% still, so we had a jump cut. We had something like this. You have, let's go to the frame range. You have this, and suddenly in the edit ref, it jumps to another position, which can be from the same take, or maybe in other situations it jumps to another take. So what do you do? Uh, so let's say that the edit ref looks like this. So in this case, it's not dramatic, but as you can see, in this frame, is jumping from one position to the next one. So let's see how we can easily, more or less easily, overcome this problem. In this case, the face expression is not dramatically different, but it can be worse. And it can be used for faces, but also for whatever in the plate, no? Like the clothes and so on. So we have main plate and target plate, which in this case is the same, but offsetted by 10 frames earlier. So what we want to do first is pick the reference frame. In this case is where they are switching is frame 1010. In this frame, they are switching from one to the next. Okay, this. Um, then what you want to do first is track with the smart vectors you already have rendered previously. Before tracking, you want to place your grid, okay? So let's say we already placed our grid wherever we would think it would be useful. Okay, so we tracked those frames. Let's, yeah, we can do it again. It asks you to select the grid to be tracked. So if in this case we want to make a 20 frames transition, we can just track uh, 10 frames backwards, 10 frames forwards. Okay, that might be enough. Then we copy this grid warp to our destination or target place, okay? Which is, this is copied here, okay. We will be using that later. And from that point, we don't need to connect this necessarily. I mean, this to the smart vectors. We can just not have this disconnected. Okay, so now we have our target plate, which is this one here. We can place a crop to optimize our time performance. And let's jump here. In this moment, what we want next step could be align the destination plate to the original plate. I already did with a simple transform because in this case it's not changing much of the perspective or so on. So you can align as better as you can the macro movement of your destination plate to your original plate. Okay, so in this case both look more or less the same, though it has some changes in the facial expression. So we will try to correct that with the grid warp. Okay, so once it's aligned, you can go to the same grid warp you had from the original plate and you copy that on your destination plate. What do you want to do from there? You go to your reference frame. In this case, it's 1110. It was before like this. We have same values in your destination grid and in your source grid. What you can do is unlink both of them and erase the values from your source grid, with this button here. You can add a keyframe just as a reference that this is your reference frame 1110, and basically that's it regarding the grids. And from there you can go 10 frames before at 1100, and you can place a keyframe. Well, you have to change your output from warp to morph. Then you add a keyframe in morph amount, and you link these values here to mix. Okay, so both are linked. So this would be the first frame where our morph is happening. So basically what you want to do when you want to stitch together two frames, two takes, or the same take in another time space, you are putting one on top of the other. You pick uh, your reference frame where this is happening in the edit ref, the change from one take to the next one, and then you add some overlapping frames backwards and forwards. Uh, so in this case, I decide to do it 10 frames before, 10 frames after. It depends if how it looks better in your case. And you place a keyframe in one in the morph amount, which will be translated to the mix as well. And you connect, in this case, your destination grid to the original plate. Your source grid is connected to your target plate, and that's it. You go another 10 frames later after your morph amount, and you just decrease to 0 in the morph amount. And let's see the result. That's basically what you need to morph between two plates. And then you can have some treatment afterwards. But basically what we see here is this phase morphing already more or less seamlessly between the two takes. What you can do afterwards is compensate what you have if you need to, if it's what the edit ref says, compensate what you did in the alignment state. Afterwards, you can animate this to bring it back to the original position of the destination plate. And then if you need to, if you think it's worth it, you can add something like that. Uh, what I have done here, I tracked the target plate with its smart vectors, and as you can see here, I remove the destination keyframes to stabilize his expression in the first frames. So that could be also helpful to match both faces better, stabilizing your destination plate in order to make it easier to match it to the original plate. Do you have questions so far? I think I'm talking too much and I have no idea how are you doing.
All good here. Thank you, Sal.
Okay, so let's keep going. Okay, so we have 10 minutes left, uh, but this would be the most practical uses I find so far. And then I have an example where I am doing an actual, let's say, traditional morphing, which goes, let's see, frame range 11, 1170 to the end. So let's go faster. I will try to show you this quickly. So we have this guy doing this expression there, and we have another character in a completely different position, expression, color, everything is different, even the format. So first of all, well, let's assume we analyze the plate, we place a crop to optimize everything, and then let's go to the destination plate, which is this one. So first of all, what we want to do is aligning more or less to the destination, to the original plate. Second, we can align that with a micro movement, let's call it, uh, with a match move that in this case is a corner pin. I know in this case it's just a transform with rotation and scale values. So I tracked our original plate just between the eyes with those values, and I transfer this information to our destination grid, to our destination plate. Okay, so we have a, let's say, macro alignment here. Next step, what we want to do, these steps are written down here, so I will share with you the script in case you want to come back and see what's going on. So we track them with a planar tracker, or in this case, a 2D tracker. Um, and then we want to track, well, first we want to place our grid in our original plate. So we draw a grid as we saw before, following the features of this guy. So it's easier to match his features to the other one and the other one to this guy. So basically what we want to do is as well an overlapping in time of both plates and bring the features from the second plate to the features of the first plate in the first keyframe, and the other way around. The features from the first plate to the features of the destination plate in the last keyframe. What we do with that is making a transition in the shape of both from A to B. Okay, so we place our grid here, and after we place this grid, we tracked this grid already. Okay, so we saw how to track them with the smart vectors. We did it already. And then we go to our last frame. And what did we do here? We are visualizing our destination plate. Okay, this is our last frame of animation. And in this last frame, we want to bring these features to these guy features. So I choose these images because, well, they are obviously very far away from where he's looking at, the color, the nose size, the lip size. So they are very far, but I was trying to do something extremely different, or uh, yeah, very different, to see if we can produce an interesting result. So in the last frame, we put an adjustment layer to the destination grid. And in this adjustment layer, I did everything I thought would be necessary to bring the features closer to the other one. And from here, we have two options. Either we place a keyframe in the adjustment layer in the first frame of the transformation, which would be the same keyframe, the same shape as the destination layer. or we can adjust the warp amount as we see here. Okay, so I did that. I choose for having a keyframe in the warp amount, and going to the first frame, I place the warp amount in 0. So it would be going from no transformation to final transformation. And then I actually copied the same grid from this guy to this second grid warp tracker. And here I did the opposite. I add a adjustment layer, bringing his features closer to these features here. So even if this looks, well, weird, funny, whatever, it will help us to make a hopefully good morphing between them. Okay, so now, and then I animated the warp amount as well, from 1 in this case to 0 in the last frame. Okay, and third step to bring this closer together is the same operation I did for preserving the light values. In this case, I call it color transfer, minusing these values to these values with a blur with the same amount, and then plussing the values back. So what this gives us is color and some lighting values transfer from the source to the destination plates. Okay. So, and then I use one tool that Tony showed us, that is the iMorph. This is actually a tool that help us morphing with an okay, this is getting slow. We are close to 10. This morph tool, what helps us is morphing from A to B, taking A, what is inside the mask, and B, what is outside. So this also helps us to contour the boundaries of what we want to morph inside the face. Okay. I think we will just have time to play the result. So the result is this. It's good that we see now frame by frame because we can see the problems we have. As we see some ghosting on the eyes and so on, but taking into account the radical difference between one image and the second, we could say it is doing some kind of a good job. Uh, okay, that's it. Do you have questions in 1 minute? Otherwise, I hope you liked it.
Thank you, Salvador.
Thank you, Salvador. Cool.
Thank you.
Thank you
I
so
will
much.
Thank you
just
so
one.
much.
Thank you. I will
Thanks,
leave
Salvador.
the script there in the templates, in the examples, in the. Well, I will share you the path.
All right, and I will upload the recording.
Super.
All right.
Thank you for
Thanks.
coming and for recording.
Thank you very much.
All
Thank
right.
you.
Bye.
Thank you.
Ciao, ciao.
Bye-bye.
Bye bye.
Ciao, ciao.